Hi everybody, hope you're doing well. I am making a video here today dealing with graphing rational functions. Most specifically, we're going to be talking about horizontal and vertical asymptotes. And then a little bit about end behavior as well. We're going to get some practice right here. And that'll be it. Okay, so these are the notes I usually write out for them. Horizontal asymptotes and vertical asymptotes. Vertical asymptotes are a bit easier than horizontal, as you can probably tell just by looking at it. But basically, vertical asymptotes with rational functions comes from the bottom of the fraction. If you have forgotten, the word rational means fraction. So in all of these things, you're going to be seeing fractions like these examples down here. Fraction, 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 fraction. And to find a vertical asymptote, you set the bottom equal to 0. So like in this one, I would say x minus 14 equals 0. And if you add 14 to both sides, you get x equals 14. And that right there is the vertical asymptote. End of story. So sometimes it's pretty easy. X equals 14 is just the vertical asymptote. If you forgot what a vertical asymptote is, it looks like this. It is a vertical line, and it is drawn as being dotted. So important, always make sure it is dotted when you draw it. That comes up later. But if you're finding it, it's just, set the bottom equal to 0, you get a number, and the equation of a line is always x equals. Because like if x equals 14 right here, the equation of a line is x equals 14. For horizontal, it's going to be y equals something. Y equals a constant means it'll just be a horizontal line. But if x equals a number, it makes it a vertical line. So same thing here. If I set the bottom equal to 0, I would add 5 to both sides and get x equals 5. And that's it for vertical. So I'm going to do vertical in red. And I'll probably just choose like horizontal I'll do in blue. So, in any old kind of type of problems, you could either go through, or we could go through all these problems and just do vertical and then come back and do all the horizontals. Which, I'll probably just do. That way I don't overwhelm you with stuff. So the first half of this video will be vertical, the second half of the video will be horizontal. Here, if you set the bottom equal to 0, it says 5 equals 0. Hate to break it to you, but 5 does not actually equal 0. That means this one does actually not have a vertical asymptote, so no vertical asymptote. Here's where it gets more interesting. When you set this bottom equal to 0, it's not as straightforward. When you have something like this, you actually have to factor it first. In this case, since it's a trinomial, you want to look for two things that multiply to -4 and add up to +3. So what multiplies to -4 and adds up to +3? That'll be 4 and 1. That'll multiply to 4. But to be 3, it would have to be 4 minus 1. So I'd have x plus 4 and x minus 1. And when you set each of these equal to 0, if x plus 4 equals 0, you would subtract 4 to get -4. Or in this one, you would add 1 to get x equals +1. So this would actually have two vertical asymptotes, one at -4 and the other at +1. Something like that, which is possible. Rational functions look really weird. Yeah, they really do. You'll get to see that. Here, same thing. If you set the bottom equal to 0, you have to factor this. It's a difference of squares. So it's going to be x plus 1 and x minus 1. And when you set them equal to 0, you get x equals -1 and x equals +1. So in my typical fashion, I recommend you guys just pause for a second and see if you can figure out the vertical asymptotes, if any, for these three. For this one, it factors into x minus 2 and another x minus 2, which means you get x equals 2 twice. You don't have to write it twice, but you do get x equals 2. Here, if you set equal to 0, you subtract 12 from both sides, and you get x equals 12. And here, it's already factored, so it's just going to be x equals 5 and x equals negative 1. And that's all the vertical asymptotes. Okay. Over here, going back to horizontal, it's not longer to find it. It's just, hey, do you remember how to find it? Because there's 3 cases. No matter what you're going to do is you're going to compare the highest degree in the numerator and denominator, meaning the top and the bottom. So if the degree is bigger on top, there's no horizontal asymptote. So like if you have an x squared over an x, then this is going to be none. If the degrees are the same, you divide their leading coefficients. So if I had like a 12x divided by a 6x, and I could put like a -1 there, it won't make a difference. All that matters is if the degrees are the same, the exponents are the same, x to the first and x to the first. If they are the same, you divide the numbers in front. 12 divided by 6 is 2. So y equals 2, in this case, would be the horizontal asymptote. And then if the degree is bigger on bottom, so if I had like an x over an x to the third, or maybe I just had a 5 over x plus 2, the degree is bigger on bottom. The exponent here is 3 versus 1. Here, the top doesn't even have an x. So then it'll just be y equals 0 all the time. Now, for those of you who like to actually understand math, this is what you do, but there's actually a consistent way to think about this, because it may seem like these 3 things are completely different, but they're actually not. They all come from the same process of B. If the degrees are the same, you divide their leading coefficients. So if you're curious as to why, you can look it up. If you're curious as to how A and C come out of B, then I'll show you right now. Otherwise, you can fast forward probably a minute and a half or something like that. What happens is that you can actually always divide the leading coefficients. So I'll just do this on some blank paper right here. Let's pretend I have 6x plus 4 over 2x minus 3. It says that since these are the same, you would divide them and you would get y equals 3, because 6 over 2 is 3. But before I said if I have like 6x plus 1 over 2x squared plus 3x minus 4, the degree is bigger on bottom. But you could technically say, no, they're not. They're the same. What? Because technically, there is an x squared on top to match it. It's just how many are there? There's 0 x squareds on top. So you have an x squared on bottom, you have an x squared on top, it's just there's 0 of them, because 0 times x squared is nothing. And if you divide these now, 0 divided by 2 is just 0. So if the degree is bigger on bottom, you get y equals 0, which hopefully sounds a little bit familiar. If the degree is bigger on bottom, you get y equals 0. And the same thing would happen the other way around. If I had x squared plus 5x over x plus 3, sorry, I didn't get that on paper, you have an x squared on top but not bottom. But wait, you kind of do. You could put an x squared here, it's just then it would be a 0 x squared, and there's technically this 1 in front. So now that the x squareds match, you can divide them, but 1 over 0 is undefined. You can't divide by 0. Since it's undefined, there's none, which should also look familiar. Boop. No horizontal asymptote. Okay, so that's the explanation. Don't know if that was a minute and a half, but I tried. So going to the practice problems. Boop. X3, this is a 1x to the third. Here, there is no x to the third, so the degree is bigger on top. So if you go up to, if you look at this above, the degree is bigger on top, it's none. Or you can do that trick I said, it's like you have a 0x to the third, and 1 over 0 is none. On the next one, it's a 1x over 1x. They are the same degree, so you divide them. 1 over 1 is 1. Here, there's an x up top, but no x on bottom, so you could think about it as like a 0x, so 1x over 0x. 1 over 0 is undefined. Or once again, you can use those rules. The degree is bigger on top, so you get none. Here, the biggest exponent is x squared. There's like a 0x squared on top to match it. So 0 over 1 is 0, so you get y equals 0. Or once again, the degree is bigger on bottom. If the degree is bigger on bottom, then it's y equals 0. So there you go. I'm a mathy person, that's why I keep explaining the matching thing. But, you can always consult the chart if you want. 3x squared over 1x squared. Oops, almost. I almost made a biggie mistake. Turns out there's an x to the 5th here. So the exponent of 5 on top is bigger than the x squared on bottom. So this would be like a 0x to the 5th down here to match it, and negative 2 over 0 is undefined. Give you a second if you want to try these yourself. This one's trickier because it's factored. But here, same degrees. 2 divided by 1 is 2. Here, there's a 7x and a 1x. They match. 7 over 1 is 7. And here it's tricky because it looks like an x and an x, but if you were to FOIL it out, it turns out there's an x squared on the bottom. You'd get x squared minus 4x minus 5, which I don't care about, but there's 2 x's on bottom, but only 1 on top. So it turns out that this is going to be 0, y equals 0. And that's it for that. Oh boy, we have reached 12 and a half minutes. Do I think I can do any more? We don't need to do that part, so we'll just finish up with this. Once again, I would just kind of pause, see if you can do it. And now I'll do it. So here, if you make the bottom equal to 0, you get x equals 4. So 1, 2, 3, 4. We're going to draw a vertical line, dotted. Here we would get 5. So 1, 2, 3, 4, 5. Here I would get x equals negative 5. So 1, 2, 3, 4, 5. As well as x equals 1. And this I would have to factor into x plus 4 and x minus 1. So I would get x equals negative 4 and x equals 1. 1, 2, oh my goodness, 1, 2, 3, 4. No one to blame but myself for making it that small. Okay, so those are the vertical. Finally for horizontal. 1x to the third over 0x to the third. That's none, because 1 over 0 is undefined. 3x over 1x. 3 over 1 is 3. So 1, 2, 3. Okay. Here, technically it's an x squared on bottom, but there's no x squared on the top. So 0 over 1 is 0. And finally, a 1x squared over 1x squared is just 1, so y equals 1. And there you go. That's graphed all of the asymptotes right there. If you're curious about this, then I was just doing end behavior Just kind of showing that if there's asymptotes, the end behaviors always go towards the horizontal asymptote. So that's what that is. If you have a horizontal asymptote, just note that the ends always go towards that horizontal asymptote. Boop-a-doop-a-doo, horizontal asymptote. Hey look, end behavior goes towards it. This one did not have a horizontal asymptote. Since it had no horizontal asymptote, they were going to do different things. Anyways, this has been much too long, so have a good one.